You may have heard terms like high-speed motors and low-speed motors, but in reality, hydraulic motors that can operate stably below 50 revolutions per minute, or even at single-digit speeds, are extremely rare. So the question is, why is it so difficult for a hydraulic motor to achieve ultra-low speed operation? The first and most fundamental challenge is that extremely low flow rates are inherently unstable. The rotational speed of a hydraulic motor is directly determined by flow rate. When the flow is reduced to a very small value, torque ripple and pressure fluctuations that are barely noticeable at higher speeds become significantly amplified. This leads to the typical stick, slip or crawling behavior, where the motor moves intermittently instead of rotating smoothly. In practice, unstable low flow is the primary barrier to ultra-low speed operation. The second issue is that friction and internal leakage become disproportionately influential at low speeds. At medium or high speeds, sufficient pressure and flow can easily overcome internal friction and leakage losses. However, under ultra-low speed conditions, friction becomes dominant, and even minor internal leakage can cause the motor to start briefly and then stall, preventing continuous and smooth rotation. The third critical factor is that the motor's internal structure inherently limits its minimum stable speed. Different motor types exhibit vastly different low-speed characteristics. Gear motors suffer from relatively high internal leakage and are therefore unsuitable for low-speed operation. Vane motors have limited starting torque and tend to become unstable at low speeds. Piston motors, while capable of high pressure, have higher structural friction, which also restricts low-speed performance. Gerotor orbital motors, by contrast, are structurally better suited for low-speed operation, but even they have practical limits and cannot operate at arbitrarily low speeds. In other words, low-speed performance in a hydraulic motor is not something that can be achieved simply by adjustment. It is fundamentally determined by the motor's design. In summary, achieving truly stable ultra-low speed operation in a hydraulic motor requires all of the following: a stable and precisely controllable micro flow, extremely low internal leakage, predictable friction behavior, and a motor structure inherently suited for low-speed operation. This is not simply a matter of turning the speed down, but a classic example of a system-level engineering challenge.